Swayam Prabha. Digital India. Educated India.
So, welcome back to the lecture series in animal physiology. So, we are into the fifth lecture of the sixth week. So, if you remember in the last lecture, we started talking about one of the memory models, which is termed as long-term potentiation. So, what we observe in long-term potentiation is, to summarize it, so say for example, our information is coming from a source at a very intense rate, and it get to a point where that is being received. At the receiver end, over a period of time, the electrical activity of that receiver end becomes higher than normal, in spite of the fact that there is no more signal coming from the sender side. Okay? If you just recollect back what we talked about, if this is, so we are into week 6, lecture 5, W6 L5. Okay? So, here we have a sender of signal, here we have a receiver of signal. There is a high train of signal which is coming. It's a very high train, okay? So, automatically this is from the center, and receiver start to respond to it accordingly with respect to time. But after a point, there is no more signal coming from the sender, still receiver is kind of responding. So, what we do not know, that is this process a presynaptic event or a postsynaptic event, because sender in this case is a presynaptic part and receiver is the postsynaptic part. But what is commonly believed is that between presynaptic and postsynaptic, there is a synaptic zone or a synaptic space, and it is being believed that at these synaptic spaces or synaptic zone, there are some form of permanent changes which are encoded. And again, this is just a belief system currently, because to tell with certainty is very difficult, because again and again the question will come back, what are those permanent changes if we have to define memory physical basis, or if it is some other form. Because as of now, as I was telling you guys in the previous class, that whenever we talk about memory, we have a physical understanding. Like we always believe, like, you know, on a membrane or on a surface there will be inscription, just like lithography, you know, you have some kind of dots, points or something, you know, and you can decode that info back, just like what used to happen in the, those of you who haven't seen that long player, olden days. So where, you know, you used to have a tip which used to, you know, tap on, and that way the song used to get recorded, and then if you exactly follow that track, something like this. So for example, there used to be a tapping, and tapping used to, you know, store information based on the sound waves on a membrane like this. Okay. Now if you play back this thing in a, if we again start to play and follow that track, it will generate exactly what you have stored. So this is what we talked about whenever we talked about the permanent changes, or at least, you know, quasi permanent or some kind of a change which is long lasting, which is happening at any surface. That's why I decode it as a memory. But in the case of biological system, this as of now remain a mysterious thing, that where that permanent change is happening. Is it at the level of a DNA, or is it at the level of a protein, or is it at the level of a membrane, or where? Or there is another option. Is it the system is governed by some wave phenomena, where many of the quantum mechanists have been exploring. So, at this stage, we are in no position to understand what is happening, but definitely in an in vitro setup, this long term potentiation or LTP phenomena is being seen, and currently, till we have any better model to justify it, we do believe that, again mark my word very carefully, we do believe that long term potentiation is indeed a process of memory acquisition. But then comes the second situation. There was another model which was suggested, which was just the reverse of it, which is called long term depression, where D stands for depression. So, long term depression is a much more practical situation. So, say for example, you are walking and on some dark alley and you just saw a snake moving through. Maybe you have seen that snake for 1/1,000,000th of a second or a fraction of a moment, but that information gets into your brain in no time, and there are certain areas of the brain where that information gets decoded so fast that in spite of the fact that was not an intense signal in terms of the frequency or time, but there are certain parts of the brain which become excitable at a much lower hertz or frequencies. They become hyper excitable. So, in other words, so if you look at this plot, what I did, so I told you there is a high frequency stream of information. It's something like, something like this, pretty high frequency. It's coming through. It is something like, you have to remember some, say, formulae of mathematics or some theorem or some laws. You are studying intensely, or you are going through certain manual, and you have to intensely remember everything, or remembering a poetry. So, it is an intense process what you are performing. It means you are like, really getting deep into it. Whereas, I gave you a counter example. When you see a snake, or somebody just showed you something, something which could, scare the shit out of you. That event, unlike this out here, if you see it, that event will be something like this. Just a moment. So, if you see the time of the signal coming, this definitely, if I say it's a T1, and this time if you see this is T2, definitely T1 is reasonably greater than T2. Okay, very reasonably greater. If you see these, compare these two green traces, but there are parts of the brain with that fraction of a moment. There are areas of the brain which gets pretty hyperactive, even with such a low trace, such a low. And such thing can happen in two situations. I'll come. So, one is what we call as emotional memories. And the area of the brain which emotional memory fear memory. This part of the brain, whether it's an emotion, whether it's a fear factor, whatever, is governed by a zone called amygdala. The name it got because of an enzyme called amygdalaceae, which is coming from, one of the nuts. So it's something like, the location is somewhere out here. It's a nut-shaped organ, pretty diffused. It's not that like, it's something like a walnut shape. So the structure is something like this. As you have seen the surface of the walnut, it is much more, gyrations and everything. So this is the zone where it is believed most of our emotional memories, memories of sorrow, memories of depression, psychic attack happens. But these are the zones which, or even fear memories are stored. These are the zones where this kind of long-term depression phenomena has been observed. And the person who was involved, or the very early people who have worked, one of them was Ito, who was instrumental in reporting this kind of thing. Later there is another gentleman who works at Salk Institute, Taras Sejnowski. He has made some significant contribution in this area. So there are several people who have been working in this other area. But this is another aspect of this long-term depression. Long-term depression could also be observed in those parts of the brain which helps you to recall some of the very trivial thing too. Something like you are riding a bicycle, and if somebody asks you that, do you remember that when you have to put your, paddle your right leg and then the left leg, and likewise. So you will laugh, of course you know it, or you are walking, there is a pattern like, right, left, or left, whichever way you walk, okay. And that pattern is kind of coded into your system. You really never need to recall that how you are going to ride a bicycle, right? I mean, most of you, if I believe, right? And so those kind of memories do not need any kind of recall process. You just do it, as simple as anything. You do not need any kind of recalling or any kind of those kind of information, those areas of the brain which decodes these kind of things falls under long-term depression. They do not need, it's over a period of time. So they may not be just an impulse, but something like, you're learning over it, and then that area kind of gets activated almost even without your realization. So both of them have one commonality if you think of it. Like without much effort, that area, you do not have to really recollect anything, that how you are going to ride a bicycle. And exactly the same way, a fear, even before you think, that fear grips you of thinking of something. So it seems to a very contrasting thing, but it seems there are areas of the brain which gets activated at a very low stimulus or almost no stimulus. Whereas on the contrary, I give you a situation, if I ask you, what is, say, Geldal process or Geldal apparatus, or if I say, okay, explain me what is Markov chain, or if I ask you some very fundamental aspect of electrodynamics, or if I ask you, explain me the whole work of Charles Darwin, it will take you some time. Unless you are teaching that subject every other day, you must have read it, but it's very unlikely that on one shot you are going to talk over it. Yes, some people can, but most of us cannot. So it means for some of the survival strategies, so one common thing if you look at this, some of the survival strategies, So one of the survival strategies is fear factor. Fear. It's a survival instinct, right? Or some day-to-day habits. We do not really need to spend a lot of energy to recall that process. Just with the slightest stimulus, we can do it. And even that stimulus, you really do not even feel that you are actually recalling something. So you are in front of the bicycle and start, you know how to ride it, and it's not a big deal. Or same way with a car, or those who are regularly driving, and just sit in the car. Or you you wake up in the morning and you go to the go in front of the mirror in the restroom and start brushing the teeth. So no one tells you that you take the brush, you are going to do it like that. Definitely, most likelihood, you are going to do it like this, right? So these are some of those aspects which we are yet to really understand their in-depth molecular mechanism, and moreover, still the central question remains out there: what is so unique about this area, or even within the hippocampus? If you look at it, it does show you the traces of long-term depression. But does these things, so a couple of questions, does this thing happen in real animal, in the real life? Is that the way we acquire memory? And if it happens, what it leads to? What kind of changes it leads to? But one thing is clear: what is appearing as we are traveling in this area is that, say for example, brain is a system which is function of space and time. What does that I mean? That means, say for example, let me just give you a very graphical representation that will make more sense. So okay, just give me a couple of minutes. Let me so let's assume 4 different time points at some point of your life. Say for example, I say this is, you are at 10 years, this is you are at 20 years, okay, 30, 40 and like on. Now in your x-axis you can draw the time. This is the time. It will go to 80, 90, whatever, how many years soever you live. So out here, the network properties or your thought process over a period of time, okay. See, if this is the summation of some way I can quantify that, So these are the information which are stored. By this time, this whole thing will have the old information as well as a set of new information getting into it. And from these two mix of green and blue, there is an emerging property which will come, which will be a new set of understanding of the system, for which you do not need any additional information, right? It is all coming from already existing one. So similarly, this pattern can go on and on to a point like, so this is what you acquire at the age of 20 and this is what you acquire at the age of 10. If these are the traces, then now you are acquiring between 20 and 30 something like this. So now all these things mix up and it creates another set of pattern out here. So if you have some way or other to distinguish between, say for example, something is changing its shape in the microstructure. So if I assume at 10 years the detailed microstructure of your brain shifts from 10 years to 20 years and it from 20 to 30, the internal microstructure of synapse formation, synapse build up. Within the synapse, the connectivity changes. So if you see over period of time, which is your x-axis, and space. In this case, space is this space of the brain, within the brain. So we see within this space, you will have changes in the micro anatomy. And what we do not understand, those changes in the microanatomy at the level of synapse, or even some of them at the level of nucleus, or in other words DNA, how those things becomes permanent. And when I say emergent property, so emergent property is that, suppose if I could give a shape to your memory structure like this, over time it changes, and then over time it further changes, much more complex. As you move on it changes. So you are seeing your brain is intact, but within it there are some permanent changes which are happening, which are function of time and space. The network behavior changes, and the central and the fundamental question which will be bogging for centuries to come will be, what are those permanent changes? What is really memory is all about? What is, if this is the, what are those physical bases? Is it at the level of matter? In terms of matter, I mean any kind of cytoarchitectural changes, or it is at the matter of wave? We do not know. So that brings us to almost like duality, a particle nature or a wave nature, and we just do not know this. Is it the whole system's wave function changes? The whole system vibrate at a certain wavelength or a frequency out there. It keeps on changing at every micro architecture. We just do not know. And this, if I assume it right, just like in physics how the quantum mechanics evolved, this is precisely the point. One day in a distant future, biology will evolve, because this is the fundamental question in biology, that what is the physical basis of memory? Is it some kind of matter, or it's some kind of wave, or is it a duality? And this is where people from quantum mechanics are so keen to understand what memory is all about. So at this stage, I will add one more piece of information and I will close in on this. So another theory is that from hippocampus, this hippocampus acts as a random access memory of the brain, and from here the memory traces are stored in different parts of the cortical region. Again, how this happens we do not know, but this is what is the current belief is, or current. So say for example something is getting processed here, at different parts of the brain they are getting stored. How these memory traces are traveling to different places, what are those functions, we do not know precisely. but it looks like something like that is happening. And the challenge for the neurophysiologist of future will be to answer some of these questions. And if you ask that what are those big questions what mankind desires to answer, definitely this is one such question. So then comes, what is loss of memory? So I'll close in here. Next class I will start the story of those souls who lose their memory. What does that mean? And what is the physical basis of it? Because probably some of our answers will always come from those individuals who goes through this ordeal. So thanks a lot, and thanks for your patient listening.